Okay, as we continue with angles, I did provide a template for you to take some of these notes on if you would like. And in that template are also some examples to practice. So if you're interested in practicing some of the problems, I also printed them out so that, or I have them for you to print out in case you want to kind of go along and take the notes on that template. So it kind of looks like this, right? And if you've got a protractor, you can practice measurement and going along with your protractor as well. But it's not necessary. You do not have to print out the examples that I gave you. You do not have to have a protractor in order to take the notes today. Okay? So we want to take a look at some angles, and we've talked a little bit about what's in this section already. I sort of gave you a little bit of foreshadowing in our past. So the first definition we want to take a look at with angles tonight are vertical angles. These can also be called opposite angles. And vertical angles are, they're the intersection of two rays, okay? They share the same vertex. This is the intersection of two rays okay? And they can also share the same vertex. So I am going to create two rays. No, intersection of two, I apologize, lines sharing the same vertex. Okay. So here's one line, here's another line. So those clearly intersect at one point. So these are okay, coplanar. Now, vertical angles are angles which are opposite of each other. So if I give you, for example, I call this angle 1, angle 2, angle 3, and angle 4, just going in a clockwise manner. Opposite angles, or vertical angles, share the same vertex and are across from each other. So I would say that angle number 1 is vertical and therefore congruent to angle number 3. They share the exact same two lines and they're across from each other, so they are congruent. They have equal measure. Angle number 2 has equal measure to angle number 4, and therefore they are also congruent. So those are vertical or opposite angles. And we have a theorem that says all vertical angles are congruent. And remember, a theorem is something that has been proven true. And, all right. So to do the proof of this, if you want to see how it's been proven, let's just do this based on what we already know. Let's think about what we already know. We know that, so here's the proof. Let's do it together. We know that if I take these two adjacent angles, okay, angle 1 and angle 2 create a linear pair or create a straight line. We know that the measure of angle 1 and the measure of angle 2 is 180 degrees because they're supplements. They're right next to each other. Okay, this is the angle addition postulate. They're a linear pair. But I can do the same thing if I say instead of looking at angles 1 and 2, let's look at angles 2 and 3, because those also form 180 degrees when I add them together. They're supplementary. So I could say the measure of angle 2 plus the measure of angle 3 is also 180 degrees. Okay? So since they're both equal to 180 degrees, I'll use the transitive property. Since both of them equal 180 degrees, that implies that if I take the measure of angle 1 and the measure of angle 2, that should equal the measure of angle 2 and the measure of angle 3. Because they're both equal to 180 degrees. Well, now a little bit of algebra says I'm going to subtract the measure of angle 2 from both sides. If I subtract the measure of angle 2 from both sides, I get the measure of angle 1 is the same as the measure of angle 3. So by definition of equal, angle 1 is therefore congruent to angle 3. And then let's take a look at complementary and supplementary angles again. So the definition of complementary angles and the definition of supplementary angles. Notice they go alphabetical. That doesn't mean anything other than it's a way to kind of remember. Complementary angles are two angles whose sum of the measures is 90 degrees. How about the sum of the measures of two angles? Am I still on the board a little bit? Two angles. Is 90 degrees. Remember, these do not necessarily have to be adjacent or next to each other. Supplementary, the sum of the measures of two angles is 180 degrees. Again, they do not have to be adjacent to each other. All right? Angles not necessarily next to each other. Okay. So, for example, let's say I give you, and you can use a protractor to measure. If you print out this template, it's going to have you practicing using a protractor. If you're unable to practice using the template that I gave you, because you don't have a printer, then you may need to practice. All right, so I would say practice, measure this angle. If I take my protractor, because it's going to be different than possibly what you have, and I put this down where the hole or the middle part here, I have a hole that goes on the vertex, and I have my zero line that lines up right at 180 degrees or at 0. Since mine's at 180 degrees, I'm going to use my inside numbers, 10, 20, 30, 40, 50, 60, 70, 80, 90. Mine ends up being exactly 140 degrees. So right now that is an obtuse angle because the measure is more than 90 degrees but less than 180. Now I'm going to take that angle and I am going to take and create two adjacent angles. together combine to make that 140-degree angle. Now, I'm just practicing. This may not be on that template, but I just want to get you practice. So if I measure the acute angle, the small one, the one that looks like it's clearly less than 90 degrees, and I measure that acute little angle, same thing, I'm going to start. If I count using my interior, 1, 2, 30 degrees, I can figure out the supplement or the other piece, okay? So if this piece is 30, but I know the entire piece is 140, then I know that its supplement would be 110 degrees in my case. Your case might be different because you may be drawing your own notes at home. So use your own protractor to determine the size of your angles, all right? All right, so we talked a little bit about complementary and supplementary last section. So they haven't changed since then. We do want to look at what's called a transversal, though. So I gave you some practice problems on that template. But I want to look at what's called the transversal. And a transversal, is a line or a line segment which intersects other lines. Sometimes they cross, sometimes they don't cross. But I do want to go over some vocabulary, so I'll try to keep this picture consistent to the one that's in that notes template. So I'm going to give you 3 lines. Okay? I'm going to give you this diagonal line. I'm going to call that line line P. Then we're going to take and we're going to have this line looking something like this. I'm going to call this line line N. And then we'll take this other line over here and we'll call this one line M. And usually you might use cursive or you might use lowercase letters to represent lines. Uppercase letters represent points or vertices. And trying to stay consistent with what I gave you on that template. I'm going to call this angle, angle 3, 1, 6, and 5. 2, 4, 7, and 8. And then we're going to look at some terminology on how we can compare them. And notice right now I did not give you any lines that are parallel. I just gave you 2 lines that are intersected and are cut by what's called the transversal. So in this case, our line P would be called the transversal. Okay, so in this case, first, line P is the transversal. And let's take a look at some vocabulary just to describe, we have a bunch of things. We have alternate interior angles, alternate exterior, same side interior. We have, so let's first look at interior angles. And then so interior angles. Interior angles are the angles that are on the inside of the 2 angles that were cut by the transversal. So here's my 2 angles, or 2 lines that were cut by the transversal. So angles 2, 4, 5, and 6 are on the interior part of those 2 angles. So those would be called our interior angles. What did I just do with the blue pen? It's right here. So angle 2, angle 4, angle 5, angle 6. And then we also have what are called exterior angles. And they're on the outside. So if I have my two lines again, and my two lines, well, these two lines, you'll notice that the angles that are on the outside of those two lines are 1, 3, 7, and 8. And then we want to get more specific. Now let's look at the interior angles. Notice I'm going to now add an adjective to describe the interior angles. I'm going to call them alternate interior angles. So I'm looking at the interior ones. So I'm not talking about these, and I'm not talking about these. I'm talking about the interior. If we want alternate interior, we want the ones that are on alternating sides of the transversal, meaning 2 and 5 are alternate interior because they are on alternate sides or different sides of the transversal P. 4 and 6 are also alternate, but they're on the inside of our two lines. So 4 and 6 would be alternate interior angles as well. So what did we say? 2 and 5. So angle 2 and angle 5 are alternate interiors. Angle 4 and angle 6 are alternate interiors. Well, now let's switch to the exterior angles. Remember, the exterior are on the outside. So, spin this around. I'm going to now cover up my interior angles. So my exterior angles, we also have alternate exterior angles. So they're exterior, so they're on the far outside of our two lines that are cut by the transversal. But now I want alternate. So angle 1 is on the same side as 8. So angle 1 and angle 7 are on alternate exterior sides. And then angle 3 and angle 8. And it's just common practice to always put the small before the large. So we're just putting the smaller number before the larger number. And then let's take a look at what are called corresponding angles. Corresponding. You might want to put this in words. Corresponding angles are located in the same position. So for example, if I look at angle number 1, notice where angle number 1 is located. It is on the right side of the transversal, and it is above angle N. So I want to find another angle that is on the right side of the transversal above angle M, line M. So you'll notice that angle 1 and angle 2 are corresponding because they are located in the same position. Both of them are to the right of the transversal and above the other line. So let's see, angle 1 and angle 2. But I could shift this just a little bit and say, well, on the right side and below would be angle 6 and angle 8. Or you could look in the others. Angle 3 corresponds to angle 4. Angle 5 corresponds in location to angle 7. So that's what we mean by corresponding. Okay. And then let's go ahead and look at, because it's going to show up in a theorem in a little bit, what's called same side interior. Same side. So same side of the transversal, interior. Same side interior. So if I use my figures again, okay, interior implies I'm only looking at everything on the inside of our two lines that were cut by the transversal. Same side. Well, same side means to the right side or the left side of the transversal. So 6 and 2 are considered same side interior. Or our other choice would be same side, here's our interior, same side of the transversal would be 4 and 5. So hopefully that helps with location. So you can see where those have all come from. Okay. So I did get a practice problem in there. If you want to practice finding and naming some of the parts and pieces using a protractor to determine some of their angles. And now I want to give you a very, very important theorem. I'm going to leave this picture over here, okay, so we can refer to what is what. But we want to take a look at what happens if these two lines that are given to you are parallel to each other. So if I have two parallel lines cut by a transversal, then all kinds of things happen. Okay, so we have a very important theorem. If two parallel lines are cut by a transversal, so that's called the hypothesis. Then, this is called the conclusion. We have 4 things that happen. Okay? So I'm going to kind of draw a picture to kind of help. This time I'm going to make the lines parallel to each other. I'm going to have to sketch it a little bit. So just slide those down. That looks pretty good for our... So here's my 2 parallel lines. We have a symbol for parallel. The symbol for parallel lines is putting like a little arrow. Okay? So I'm going to call, hold on, let me see what I called them. I called them N and M again. N, M, and we're going to cut line by the transversal. I'll call this line P. And we can number them the same as what we just did. 1, 3, 5, 6, 2, 7, 8. So I'm using this same setup, but this time I made these two lines parallel to each other. Because we already know what they're all called in relation to each other. But if the two lines are parallel, then we have a lot of special relationships going on. Okay? We have the fact that, because like we now know 1 and 5 are vertical or opposite, so those are going to be congruent. So we have a few things that happen here. One, alternate interior angles. Oh, sorry about that. Alternate interior angles are congruent. So now I know angle 2 and angle 5 are congruent. Angle 4 and angle 6 are congruent. Angle 2 congruent to angle 5. Angle 4 congruent to angle 6. We also know that alternate exterior angles are congruent. So alternate exterior. So that's 1 and 7, 3 and 8. Alternate exterior. So angle 1 is congruent to angle 7. Angle 3 is congruent to angle 8. And that one's fairly quick to prove in that if I know 3 is congruent to 6 because they're opposite of each other, but I know 6 is congruent to 4 because they're alternate interior, and I know 4 is congruent to 8 because they're vertical angles. Well, now you have the measure of 3 equals the measure of 6, which equals the measure of 4, which equals the measure of 8. So therefore, 3 and 8 have the same measure. Therefore, they are congruent. Same side interior angles are supplements. Same side interior angles are supplements, meaning that they add up to 180 degrees. So same side interior, that would be 5 and 4. So the measure of angle 4 plus the measure of angle 5, they're supplements, so they equal to 180. Measure of angle 2 plus the measure of angle 6 are also 180. And if they are parallel, the last piece of information is that corresponding angles are congruent. Remember, corresponding meant that they were sitting in the same location. So when we did this before, angle 1 and angle 2, angle 1 and angle 2, they're both above the parallel line to the right of the transversal. So therefore they are congruent. So angle 1 congruent to angle 2 because they're sitting in the same location. Looking on the right side, I can see that 6 and 8, angle 6 is sitting in the same location as angle 8, so they're congruent if the lines are parallel. And you finish out with the other two sets are. If the lines are parallel. All right. And last last section, we talked about finding the measures of some polygons. I want to write it down again. We talked about finding the measures of the interior angles of a polygon. And if you recall, that was all based on given a triangle and its 3 angles and adding them together. So I just want to kind of refresh, write this down, okay? Because we did this before. We said the sum of the interior angles of any polygon remember, we took the polygon and we divided it into a bunch of triangles. And once we did that, we found that this was always the number of sides minus 2 times 180 degrees, where n is the number of sides, or the number of angles. Or angles. Now, we also said, if you remember, might as well just put it here again, the sum, nope, not the sum, the individual angle. The measure of a single angle of a regular polygon. I'm just going to keep going. The measure of each angle of a regular, meaning all sides are the same, all angle measures are the same. We started with the total sum, and then we divided it by however many angles or sides we had. So we talked about that last section. Now the question is, what if the angles are exterior? What about the exterior sum? Okay? Question. What is the sum of exterior angles? Of a polygon. Well, let's figure it out, okay? Let's figure it out. We can either figure it out with a triangle, a square, pentagon, hexagon, any of them. I'm going to choose a square because I think that's a nice one. Let's say, for example, then we'll do a triangle or a pentagon. Let's take a square or a rectangle, either one. After all, a square is a rectangle. A rectangle is not a square. But in that chart that it went over with you on, I think it was page 644 or something I gave you. Okay? A square or a rectangle, by definition, they have 4 90-degree corners. Okay, they both have 90 degrees. Well, let's go ahead and do the exterior angles. I'll switch colors here. I'll do the exterior. Let's look at the exterior angles. Well, in order to do the exterior angles, remember we take and extend this side. And then I'm going to extend this side. Then I'm going to go across and extend this side. And I'm going to come down. I'm going to extend the other side. Well, we know that there's 180 degrees in any straight angle or straight line, which means if this interior is 90, this exterior is 90, this vertical line has an exterior of 90, horizontal line has, an exterior, here it is, of 90. And if I go back to this vertical, this piece right here has 90. So therefore, the sum of the exterior angles would be 4 times 90 degrees, or 360. Let's do it again. I'm going to pick a triangle. I'm going to pick a triangle that's not equilateral. I'm just going to make up some sort of triangle. I'm going to make this a little larger. Easier for you guys to see if this is larger. Here, we'll make it obtuse. It does not matter at all, but I'll make it obtuse. And I could either actually measure them, or I'm just going to estimate, tell you that this angle, let's call that 110 degrees. We'll call this angle over here 40 degrees. And I know they all have to add up to 180. So right now the sum is 150. So this one would have to be 30 degrees. And let's find the sum of the exterior angles. So what we need to do is extend each side. So either going clockwise or counterclockwise, just start with one of them. I'm going to extend the 110 degree angle. So first I'm going and extending this one. Then if I go clockwise, my next side, I'm going to extend this angle, this side rather. And then if I keep going, oh, I should have held it down. I apologize for that. Okay. And now, as I look, I need to figure out those angle measures of those exterior angles. If I start at the top with that 110 degrees, and I know I have a straight angle, this supplement has to add up to 180, so that piece is 70. This pair of adjacent angles next to each other, it's a linear pair. They have to add up to 180. They're supplements. So 40 plus 140 is 180. Similarly, this is a straight angle, straight line, 180 degrees. So the supplement of 30 is 150. So if I add together 150, 140, and 70, I get 0, 9 and 7 is 16, carry the 1, I get 360 degrees. So this is through examples and deduction, okay? Through observation and examples, we can probably come up with the sum of exterior angles. So the sum of exterior angles of any polygon is 360 degrees. That's how I used to do it in my notes when I didn't want to put a whole box around it. I would just sort of box part of it. All right? Okay. And then we talked a little bit about this last time with the interior angles. And I want to do one example where maybe you have some interior angles and we want to find some missing measures. So I'm going to finish it up with one example. Sort of ties back into last section notes. It is one of the examples I put in that template and practice problems. So I'm going to sketch, and I want to find the measure of the missing angle. Find the measure of the missing angle so this is, we've got a pentagon. I'm going to sketch it so it may not be drawn to scale exactly with using a compass. So I'm going to come up, across, shorter, longer, not that long. Whoops, a little crooked. All right. And I'm going to tell you that, going clockwise, I do not know this angle. This is angle X. Clockwise, this angle is 80. This angle is 133. This one is 92. And this last obtuse angle is 113. So what we want to do is we want to figure out how large angle X is without a protractor. Without a protractor. So if I know the sum of all the angles on the interior, I can deduce and find out what X is. Well, we know the sum on the interior angles is n minus 2 times 180, or, personally, I usually don't think about that formula. I usually figure it out by going, well, let's see, the sum of interior angles is, and remember how we just divided this into a bunch of triangles? One triangle, two triangles, three triangles. So I have n minus 2 times 180 if you want to use the formula, or if I divide this into three triangles, that makes sense because there's 5 sides. 5 minus 2 is 3 triangles, of which each of them has 180 degrees. So I know the total sum should be 540 degrees. So the sum of the interior. So I'm just going to follow what the left hand says to do. The left hand side says take the sum of the interior. Okay. That would be X plus 80 plus 133 plus 92 plus 113. Okay. And now if we do the arithmetic and I add all these together, X plus, I don't know what that is off the top of my head. I didn't pre-do this problem. Let me clear this all out. If I take 80 plus 133 plus 92 plus, I get 418 degrees. So bring the 418 to the other side by subtracting, and I should get 122 degrees. So that's how big our missing angle is. You can either use the formula to calculate the sum of the interior, or you can just divide it into triangles. Okay? So there's a little bit more practice with some angles. Hopefully that was helpful, and see you next time.